Hey y'all, welcome back. Today we are reviewing for the TSIA2 and specifically we are focusing on geometry questions. Number 1 says, Michaela wants to retire her bathroom floor. She does not need to tile underneath the bathtub. According to the drawing below, what is the area of the bathroom floor that she needs to be retiled? So the formula here for the area is, since we only want the area that does not need to be retiled, the strategy here is going to be to find the area of the overall outside, this bigger rectangle. Find the area of this rectangle here, and then subtract away the area of the bathtub. And if you do that, you'll be left with the area that you're really interested in, which is this yellow area here. So conceptually, we want to find the area of the big rectangle and subtract away the area of the small rectangle. So the big rectangle is 8 feet by 6 feet. The small rectangle is 5 feet by 2 feet. So this would be 48 minus 10, which is 38 square feet. Oh. Number 2 says the formula for the perimeter of a rectangle with length L and width W is given below. If a rectangle has a perimeter of 24, what could be its length L and width W? Now this one's a little tricky because you're not going to be able to solve for this directly by setting up an equation and solving, because we've got only one equation with 2 variables here. Instead, we are going to just try each answer choice and find the one that works. So we'll just test these one at a time. So for A, we got the perimeter is 2 times 2 plus 12. Okay, so we're just plugging the L and the W and the length and the width in. 2 times 14 is 28. Okay, that is not going to be the answer we're looking for. We're looking for the perimeter to be 24. For choice B, we've got 2 times 4 plus 20. 4 plus 20 is 24. And 2 times 24 is 48. So that is not going to be correct. For part C, we've got 2 times 5 plus 7. 5 plus 7 is 12. 12 times 2 is 24. So that looks like that's going to be our answer, but let's just double check the last one here. 2 times 8 plus 3. 8 plus 3 is 11 times 2 is 22. And that is not going to be correct either. So yeah, the correct answer here is C. Number 3 says, Steve has a square patio with sides of length 9 feet. So I'm going to sketch out that square patio. It's a 9 by 9. He plans to enlarge it to a rectangular patio by increasing the length by 3 and the width by 2. So if we increase the length by 3, the new length is going to be 12. And the new width, if we're increasing that by 2, will be 11. So this is the old patio. Here's the new patio. We want to know how much bigger in square feet will the new patio be compared to the old patio. Well, let's find the areas of each one. The area of the old one would be 9 times 9, which is 81 square feet. And the area of the new patio would be 11 times 12, which is 132 square feet. So the difference will be, what would that be? It would be 132 minus 81, and feel free to use a calculator here, but I'm getting 51 square feet, so our answer is D. Number 4 says, if the length L of a rectangle is 3 less than twice the width W, which of the following gives the length of the rectangle in terms of the width? So you don't really have to do too much algebra or geometry here. You really just have to be able to read this and translate what it's saying into an algebraic equation. So it says the length L, so I'm going to write L of a rectangle is, that's going to be the equals. So this is L equals 3 less than twice the width. So twice the width would be 2W, but if it's 3 less than that, and this is probably the trickiest part of the whole thing, is we actually want to subtract 3 from twice the width. And even though in English you say 3 less than, like before you're saying twice the width, algebraically you would subtract the 3 afterwards. So our answer is B. Number 5 says if a triangle has side lengths of x, x plus 2, and x plus minus 4, what is the perimeter of the triangle in terms of x? So if we have a triangle, and I'll just sketch that out with side lengths x, x plus 2, and x minus 4, and I'm not going to bother trying to draw this to scale or anything. If we're trying to find the perimeter, we need to add up all of the side lengths. So just add up all the side lengths. So here the sides are x, x plus 2, and x minus 4. So we want to add all those 3 up, and we can do that by combining like terms. X plus x plus x is 3x, and then 2 minus 4 is minus 2. So our answer is B. Number 6 says, what is the area of a square that has a perimeter of 24 feet? So if it's a square, that means all 4 sides are the same. And if the perimeter is 24 feet, that means we have 4 sides that if we add them all up together, we get 24 feet. So if we want the length of just a single side, we can divide both sides by 4 and get the side length, which is 6 feet. So we've got a square that has a side length of 6, and we want to know what is the area. So 6 times 6 is 36. Our answer is B. Number 7 says a square has an area of 36 square centimeters. What is the perimeter of the square? So if the area is 36 square centimeters, and it is a square, so both sides have to be the same, we have s squared equals 36. If we take the square root of both sides, we get the side length, which is 6. So this must be a 6 by 6 square. And if we're looking at for the perimeter, we need to add up all the sides. So 6 plus 6 plus 6 plus 6 gives us the perimeter. And let's see, that'd be 12 and 12. That'd be 24 square centimeters. Or not square centimeters, just centimeters. Now, perimeter is a distance, not an area, so the units should not be squared. Number 8 says a rectangular swimming pool is X meters wide. I'm going to go ahead and just start drawing this out. So we've got this rectangular swimming pool. It's X meters wide. The length of the pool is twice as long as the width. So this would be 2X down here. If the perimeter is 64, which of the following equations represents the given information? So the perimeter is 64, and the way that we find perimeter is by adding up all the sides. So I'm actually going to label the other 2 sides here, even though they're just the same. I think it'll be easier to visualize it. So the perimeter will be x plus 2x plus 2x. We're just adding up all 4 sides. And so even though the order might be different, and actually doesn't look like it even is, but even if it said like 2x plus 2x plus x, that'd be fine. If you did x plus 2x plus x plus 2x, that'd be fine. You can rearrange the order any way you want because addition is commutative. But it says the perimeter is 64, so the answer here is A. Number 9 says if the cost of carpeting a floor is $2.50 per square foot, how much will it cost to carpet a rectangular floor that is 10 feet by 12 feet? So let's first find the area of that carpet. It's 10 feet by 12 feet. If I multiply 10 by 12, I'm going to get my area, which is 120 square feet. Now, if the cost of the carpeting is $2.50 per square foot, then to find the total cost, I need to multiply that 250 by 120. This is going to give me the total cost. Let me just maybe move that down a little bit so you can see it a little bit better. So the total cost is $2.50 times 120 square feet. And this is something you'd want to throw into the calculator, but it comes out to $300. Number 10 says figure 2 is a 90 degrees clockwise rotation of figure 1. Which of the following angles in figure 2 corresponds to A in figure 1? So this one's kind of hard to really like show without doing an animation or something. But basically, we're going to take this figure, and I'll kind of focus on angle A here and say, okay, so angle A is this way. But if I rotate this 90 degrees, like just pretend like I'm taking this parallelogram or whatever quadrilateral it is, and I'm attaching like a stick to it, okay? So just you're gonna have to use your imagination here. And I want to rotate that 90 degrees. Okay, so 90 degrees is like this. Okay, 90 degrees clockwise. And then so this whole figure, like this angle up here, angle A is going to correspond here. This is just going to be our answer to angle Z or vertex C. Vertex C will correspond to vertex X. And basically every vertex is going to move 90 degrees clockwise. So A is going to go to this one. D will become Y. C will become B, X. And then B will become W. So they're kind of rotating clockwise here. So that means A is going to correspond to angle Z. Number 11, we've got a cylinders, and the formula for the volume of the cylinder is given. And we want to find the volume in terms of B if the radius is 2B. So I'll just say the radius here is 2B. The height is 5B plus 3. And the volume is pi times r squared times the height. You do not need to memorize that formula. So if the radius is 2B, so I'm going to replace that r with a 2B, and the height is 5B plus 3, we want to essentially just simplify this and to get our answer. So 2b squared is the same as 2 squared is 4, and then we have b squared times 5b plus 3. And our last step is going to be to distribute this term right here. Now I'm going to actually rewrite that to make it a little easier to read, especially because looking at our answer choices, notice they have like the pi before the b's and in between the coefficient. So I'm going to rewrite that term as 4 pi b squared, and then I'm going to distribute that to the 5b and the 3. So I'm going to use my distributive property and multiply this term by both 5b and 3. 4 times 5 is 20, and then we have that pi. B squared times b is b cubed. And then for the second term, I've got 4 times 3 is 12, so 12 pi b squared. So our answer is B. Imagine that. What is the volume of the cylinder in terms of B? And the answer is B. What are the odds? Okay, number 12. The area of the triangle above is 21. What is the value of X? Now, I'm going to show you how to work this out algebraically, but I also want you to see that there is a way easier way of solving this one. Now, the area for a triangle is 1/2 base times height. And so if the base is x plus 1 and the height is x, we can rewrite this area formula as 1/2 times x plus 1. We can distribute that 1/2 to get 1/2 x plus 1/2. We still need to multiply that by an extra x though. So if I distribute that x, I'm going to get 1/2 x squared plus 1/2 x. And this area, it says, is 21. And so we need to find the x value that will make this true. Now, there's a couple of ways you could handle it from here. One is to actually solve this like a quadratic, and at least in my course, we haven't really talked about how to do that yet, although you did do that back in Algebra 1 and Algebra 2. I would actually suggest against trying to solve this for x using factoring or the quadratic formula or anything. You could definitely do that, but I think it'll be really easy, or I should say much easier, if you just test these values in the answer choices to see which one gives you an area of 21. So, or just test the values. Now, You don't even have to have done all this algebra here. If you know the area is 1/2 base times height, you could just use the kind of the original equation that we set up and say, okay, what's the area here? So the area is 1/2 base times height. And so I'm just going to test if x is 3, what is the area? And we're looking for the one that gives me 21. So let's check A. And if I plug in 3 for x, my area is going to be 1/2 times 3 plus 1 is 4 times the height, which is 3. All right. If I check choice B, I'm going to get 1/2 times 7 times 6. If I check choice C, I'm going to get 1/2 times 8 times 7. And finally, choice D, I'll have 1/2 times 12 times 11. And each one of these you can put into the calculator. You don't need to do any of this by hand, although these numbers aren't too big, so you might be able to. But here the area is 6. For B, the area is 21. For C, the area is 28. And for D, the area is 66. So you can see that clearly the answer is B. I would definitely avoid trying to solve this one as a quadratic because it's going to be way more effort than you really need to do. We want to be taking advantage of the fact that this is a multiple choice test. So don't feel bad about just testing out those answer choices. That is a solid strategy. On number 13, it says, in a right triangle, the hypotenuse measures 15 and one leg measures 12. What's the length of the other leg? So I'm going to draw out this right triangle. The hypotenuse is 15 centimeters. One of the legs is 12, and so I'm looking for the other one. I'll just call it x for now. We're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared, with c being the hypotenuse. And so I'm going to just rewrite this as, let x be my a here. X squared plus 12 squared equals 15 squared. Throw this in the calculator. 12 squared is 144. 15 squared is 225. I want to subtract 144 from both sides. So 225 minus 144 is 81. And then if I take the square root of both sides, I'm going to get x equals 9, which is our answer. Number 14 says, what is the perimeter of a square with side lengths of 12 feet? Well, if we've got a square, all the sides are the same. And to find perimeter, we just add up all the sides. So you could either just add these 12s up individually, or you could just multiply 4 times 12 since they're all the same. But either way you want to solve this, you're going to get 48. Number 15 says the measure of central angle ABC is 90 degrees. What is the area of the shaded sector? So here we want to take the area of the overall circle, which is pi r squared, and then multiply it by whatever fraction is being shaded in. Since this angle measure is 90 degrees, we're going to multiply that by 90 over 360. So whatever the central angle is, just divide that by 360, and that will essentially tell you what fraction of the area you want. So to get the area of this sector, 90 over 360, that actually reduces to 1/4. You don't necessarily need to know that, but it does, which means that this is 1/4 of the overall circle, which is why we're multiplying 1/4 by the area of the whole circle. The radius here is 6, so pi times 6 squared. And then we just want to simplify this. Now, when you put it in the calculator, first notice that all of the answer choices are in terms of pi. So we don't want to actually multiply pi in when we're typing this in. We just want to multiply 6 squared times 1/4. 6 squared is 36, and then divide by 4 is 9. So this is going to be 9 pi. And then our units are not given, so we're just going to say square units. Number 16 says the fountain with a circular base has a radius of 6 feet and is surrounded by a circular path that has a width of 2 feet. What is the approximate area occupied by the path alone? So in other words, we are looking for this area, okay, not the whole circle area, just the area in between the circles. And we're going to approach this actually like the very first problem we did up here with the bathroom, where the strategy was to take the area of the larger shape and subtract away the area of the smaller shape that we don't want. And that is going to be exactly what we do here. We're going to find the area of the large circle and then subtract the area of the small circle. So we want the area of the big circle minus the area of the small circle. Okay, that'll find us like sort of the overall area, and then we'll take away all this stuff in here. So area of a circle is pi r squared. So this would be pi times, now be careful, the radius of the big circle is not 2, it's 6 plus 2, which is 8. So pi times 8 squared minus pi times the radius of the smaller circle, which is 6 squared. So this would be 8 squared is, 64 pi minus 36 pi. Since all these answer choices are all rounded decimals anyway, you're probably better off just typing this into the calculator at this step. But if it were in terms of pi, you'd have 64 minus 36, which would be, that'd be 28 pi. Is that right? Yeah, I think that's right. Yeah, that looks good. And either way, you know, whether you want to type in 28 pi or just go back to the beginning and type pi times 8 squared minus pi times 36, you should get the same answer either way, which is approximately, this document's jumping all around on me, approximately 87.96. So our answer here is A. Number 17 says the parallelograms pictured are similar. Find the values of x. So this is, you have similar figures. That means that the corresponding sides are proportional. So we need to set up a proportion. 5 corresponds to x, 6 corresponds to 12. So one way you can set up the proportion, and I'll emphasize that there are other ways you could correctly set it up as well, but it's to do 5 is to x as 6 is to 12. You could flip both of those fractions and be fine, and there's actually a couple other ways you could set up this proportion, but I'm just going to set it up this way. Once you have that proportion set up, you are going to use the cross products property and multiply 5 by 12 and x by 6 and set those products equal to each other. So we get 6x equals 5 times 12. 5 times 12 is 60. And if we divide both sides by 6, we're going to get x equals 10. Number 18 has a couple more of these similar figures. Number 18 says the trapezoid's pictures are similar. Find the value of x. So we're going to set this up exactly the same way as we did the last one with a proportion. Here, 8 corresponds to x and 6 corresponds to 9. So we can set this up as 8 over x equals 6 over 9. And once again, use the cross products property. Multiply 6 times x, 9 by 8, and set those two products equal to each other. So 6, 8 equals 9 times 8, which is 72. And then if I divide both sides by 6, and feel free to use a calculator here, 72 divided by 6 is 12. Number 19 says the point negative 3, 5 is translated 4 units to the right and 2 units down. Where are the coordinates of the translated point? So negative 3, 5, 1, 2, 3, and then 1, 2, 3, 4, 5 would be here. Now if we take a point and we go 4 units to the right, that means we want to add 4 units to x. And if we go 2 units down, we want to take our y coordinate and subtract 2. Now, with the grid, you can just kind of follow the point. You don't necessarily have to come up with that mapping rule, but we can use it to check our answer to make sure we got it right. So I'm going to take this point, this original point, negative 3, 5, which is right here, and go 4 units to the right, 1, 2, 3, 4, and 2 units down. That's going to put me right here. So that point's going to be 1, 3. And that's our answer. But we can also use the mapping rule to see if that checks out. If I start with negative 3, 5, and I add 4 to 3 and subtract 2 from 5, that's going to give me 1 comma 3. Same thing. And that brings us to our final problem here, number 20. It says, which figure represents the image of parallelogram LMNP after a reflection across the y-axis? So the y-axis is this line right here. And so we're going to take that quadrilateral LMNP, that's this one right here. Well, let me maybe just kind of outline it a little bit more obviously. This parallelogram here, and reflect it over the y-axis. So for each point, we're going to sort of count the number of units from the y-axis and then reflect it on the other side. So point L, for instance, is 1, 2, 3 units away from that line of reflection. So we need to go that many units in the other direction. There's not really, once you kind of see where that should be, it kind of gives away as far as what the answer is. But you can test all these other points to make sure that they are the same distance away from that line of reflection, and they are. And so our answer here is B. And that does it for tonight's review. Please reach out if you have any further questions or want clarification on any of these problems, and I am happy to help. But otherwise, thanks for watching, and y'all have a great day.